everyone. Today we are going to see how you can determine that if the two lines are parallel or not given the equation of the lines. So first of all, I'll tell you the condition that is required, that for parallel lines, slope of the two lines should be same. First condition is same slope. That means if a line has a slope m1 and the other line has slope m2, they should be equal. This is the condition number 1. Then the condition number 2 is that we usually ignore, that is different y-intercept. Different y-intercept means that they should cut the y-axis at different points. Now, in order to verify these two things, we have to use the example. I'll give you two different examples that will tell you that why it is required that both of these two conditions should be met in order to check whether the two lines are parallel or not. So I'll write two examples. One example will be here and another will be here for the sake of comparison. So we will see example 2. So in example 1, we have the equations as y is equals to 3x plus 5 and 5y minus 25 equals to 15x. So these are the two equations for which we have to check whether these two equations are representing the lines that are parallel or not. So for that purpose, first of all, we have to convert both these equations into the standard form so that you can easily find the slope as well as the y-intercept. So the step number 1 is convert them in the standard form. So standard form of linear equation is y is equals to mx plus c. Here m is the slope and c is the y-intercept. So let's write the equation number 1 and let's check whether it's in standard form or not, or we have to convert it. So it's clear here that the equation number 1 is already in the standard form. So we need not to convert it. So we'll convert equation 2 in standard form. That is y is equals to mx plus. So let's see how you can do that. 5y minus 25 is equals to 15x. So as according to the standard equation y is equals to mx plus c, we have to keep y on one side of the equality and we have to move the rest on the other side of the equality. So 5y is equals to 15x plus 25. So y will be here. We will divide 5 on both sides according to the rule of math. So it will be 3x plus 5. And now this will be the equation number 3. Now we have to deal with equation number 1 and 3 only. We have to skip the equation number 2 because we have converted it into the standard form. Now the next step is we have to find the slope as well as the y-intercept. So for that purpose, we have to compare the equation number 1 and 3 with the standard equation, if I say it as 4. So we have to compare equation 1 and 4 and 3 and 4. 4 is the standard form, so we have to compare it. Why? Because we have to find the unknown, that is the slope as well as the y-intercept. So the slope of equation 1 and 4 will be, if we compare equation 1 and 4, we can see that the slope of equation 1 is 3 because it is representing the m of the standard equation. So it means the slope of the equation 1 is 3. If I say m1 is the slope of equation 1, and the y-intercept, that is c of the equation 1, is 5. This is the 5 as it is representing this c. So c is equals to 5. Now let's see, if I say c1 is equals to 5, that is the y-intercept of the equation 1. Then what will be the slope and y-intercept of equation 3? It can be seen easily that this 3 represents the slope. So you can say that m2 is equals to 3 and this 5 represents the y-intercept. So c2 is equals to 5. Now it is clear here that condition 1, that is m1 is equals to m2, is being met, but the condition 2, that is different y-intercept, is not met here. So you can say that the two lines are representing the same lines. Only the second line is the scaled version of the first line. So it means both the lines are same. They are both intersecting the y-axis at the same point. They have the same slope. So these two equations are representing the same line. So I can say that equation 1 and 2 represent same line, not the parallel line, because they are meeting the condition number 1 of parallel lines but not the condition number 2, that is the different y-intercept. Now let's have another example in which we can see how you can check whether the two lines are parallel if you have the different y-intercept as well. So the equation is, I write here y is equals to, so here we have the equations y minus 2 is equals to 3 by 4x, and another equation is y is equals to 3 by 4x minus 5. So these are the two equations for which we have to check whether these two equations representing the lines are parallel or not. So our step number 1 is we have to convert them into the standard form. As it is clear that equation 2 is already in the standard form, if I say that it's in standard form, but it is the equation 1 is not, so we have to convert equation 1 in standard form, that is in y is equals to mx plus c form. So how we can do that? Let's see. We'll write it as y minus 2 is equals to 3 by 4x. What I have to do only is I have to move 2 on the other side of equality, and it's now in standard form. So this is the equation number 3. Now we have got the equations in the standard form. Our next step is to compare the equations so that we can get the slope and the y-intercept. So I'll write here compare equation 2 and 4. 4 is the standard form of equation, that is at mx y is equals to mx plus c, that I have already referred, and 3 and 4. So while comparing, if I see that 2 and 4 equation, I can easily say that this is the slope, that is m1 is equals to 3 by 4, and this is the minus 5 is the y-intercept, that is c1 is equals to minus 5. And now if I see the equation 3 and 4, if I compare them, so it's clear here that 3 by 4 is the slope, that is m2 is equals to 3 by 4, and c2, that is the y-intercept, is equals to this 2. Now it is clear here that m1 and m2 are equal, they are equal, while C1 and C2 are not equal, they are different. So they met both the conditions of parallel lines. It means that the equation 1 and 2 are representing the lines that are parallel. So these are parallel lines. If I write here parallel lines. So this is why we need to check the y-intercept as well to make it clear that the two lines are different, lines are different and they are parallel, rather than that they have the same y-intercept and they are representing the same line. So that's all from today's lecture. Thank you.